I'm sorry, I'm getting confused.
We have a briefing and planning meeting.
I think it'll be dry enough all the way out to here.
10:30 we're starting to suit up. There were 3 days that we started suiting up between 5 minutes of 10:30. Nobody said it should be 10:30. That pattern just developed, and that's what I'm looking for.
I have a special perspective to bring, which is a form of science that is focused on the people and the habitat and the operations, as opposed to being focused on the crater, the rocks, and the life. So you have scientists studying the crater, and I'm studying the scientists. Having people living and working here, it isn't just a theory. We're able to watch it in context and get a sense of what people need and what they prefer to do.
Studying how people use this habitat should help in designing the actual spaceship that ultimately takes humans to Mars. And watching how crews organize their time and interact with one another should help in planning schedules and procedures on a real Mars mission.
Bon appétit.
The forecast has just arrived from the Canadian Arctic Weather Service. Cloudy with a few showers. Winds light. High of 6 centigrade.
It's day 10 in the Mars simulation, the last day for crew number 2. Off and on rain all week, very unusual in the Devon Island desert, has repeatedly delayed the second deployment of Vladimir's seismic instruments.
1, 2, 3.
Now the crew has run out of time, so despite the bad weather, they're heading into Devon Island's meteor impact crater to look for underground water.
The instruments that we are using is basically 3 huge boxes. A total combined weight is 130 kilos. We had to carry these 130 kilos on the trailer, in the crater and in the mud and so on. We had good hope that we could do it, but good fate was not with us today.
The crew had not surveyed their route ahead of time, and 2 miles from the habitat, there's a nasty surprise.
The other 3 of us believe that the ATVs will not be strong enough. We can't even stand anywhere near it anymore. We're sinking in up to our knees. Over.
On Mars there's no mud and liquid water, but a similar sort of thing can happen in dunes, sand dunes in Martian deserts. If you got really stuck in a sand dune on Mars, let's say with a vehicle and a trailer, you'd be in real trouble, possibly a terminal EVA on Mars.
What's supposed to be a practice for finding underground Martian water quickly turns into a test of the crew's ability to solve the kind of difficult problem that will inevitably crop up on a human mission to Mars.
11 to fix 1. We have removed Vladimir's ATV and the crew.
The crew gets the ATV out of the mud quickly, but now the problem is the trailer full of heavy equipment.
Why don't you back it up?
He said to pull it.
Reverse!
Is it possible to drive an ATV back there, put the luggage on and take it? No. Okay.
Can we not try what I was suggesting?
There was some moment of uncertainty, moment of indecision on what to do.
You don't understand, Vladimir. That trailer's not getting out of there unless it's unloaded.
I agree.
The problem with mud also is that there is a time problem there. The longer you stay at the same position in the mud, the deeper you sink.
Not only are they sinking, but their boots are sticking to the permafrost ice that's just 18 inches beneath the surface. After struggling 45 minutes, there's a breakthrough.
We're moving.
The trailer is free, but not Vladimir.
Oh! Please! Come and help me! Oh! Come and help me, please! Oh.
Frustrated by the whole experience, the crew loses patience with their spacesuit helmets and gloves, which would have meant instant death on Mars.
Well, this would be a pretty bad day on Mars.
After spending 1 hour pulling the ATVs and the trailer out of the mud, well, we decided to just abort the expedition and to come back to the hub.
The expedition turns out to be just the sort of group test that astronaut crews will have to face before really going to Mars. And this crew has mixed feelings about its performance.
Whoa. Whoa. Now that was an EVA. That was the epic. That was the pinnacle of all EVAs. Nothing will beat that. We've gone down in history. It was sort of disastrous, mixed in with a small amount of incompetence. But within it, there was glory.
Yes. We have discovered mud on Mars.
First thing, I'm very disappointed. Of course, we did not succeed in deploying anything, so we do not have any measurement, and I'm disappointed for that. The second thing, in the dynamic of the group, some of us did not actually put really the hand into the mud and push or pull whenever it was needed. But this is something which I feel should not happen on the field like we were today. I have no data, simply.
So on Mars, you'd have 455 more days.
Sure.
Today, the Devon Island simulation turns its attention to the enormous crater located right next to the habitat.
So, if you want to orient this as it is on this map, okay, north is this way, towards Charlie. And now our habitat base camp is right here, on Haynes Ridge. That's home. And the crater, you can even see the rough circular outline of it. What makes this place exceptional is that it bears one of the largest impact craters known on our planet, the Houghton Crater. It's a meteorite impact crater that was created 23 million years ago. The boundary of the crater runs around like this. It's 15 miles across. This is the crater roughly. It is the result of the impact of an object, an asteroid or a comet, we don't know, that was perhaps half a mile across. Impact craters are important on Mars. They are a very common, ubiquitous geologic feature. If you're interested in learning how to explore Mars and at the possibilities of life there, impact craters become a very important target. Not only are they just holes in the ground, but they are also places that have experienced heat and perhaps liquid water for a time. There are shocked gneisses.
Many scientists believe the rocks around Martian craters, having been melted and cracked and bathed in water unfrozen by the meteor impact, might be a good place to look for life.
That's where they were originally.
My name's Charles Crookell. I come from the British Antarctic Survey in Cambridge. 123 testing. And I'm a microbiologist. I study microbes in extreme polar environments. So what I also want to do is to break this open and actually carve out some rock from the inside. My personal prejudice is that we will find evidence of past life on Mars. If there was life, it would probably be very, very simple bacteria. Yeah. Maybe the sorts of things that live underground and live off very basic chemicals.
With Martian life in mind, Charles and 3 others prepare to go out into the crater.
1, 2, 3, you read?
On a real Mars mission, astronauts will most likely breathe pure oxygen during their EVAs to compensate for the low pressure of their spacesuits. Such low pressure is needed to keep a suit from ballooning up and stiffening in the thin Martian air. Maintaining the spacecraft itself at low pressure would be convenient, except that the required high oxygen would create a fire hazard. So Mars astronauts will have to transition from high to low pressure and low to high oxygen every time they go outside, just like the crew is simulating here.
Pressurization is now complete.
You are a go for EVA.
The crew has to spend half an hour depressurizing in the airlock before they can come outside. But at last, they're heading to their destination, a place deep in the crater where they can find rocks that were smashed and beaten by the meteor.
This is fairly rugged terrain, and there's even rougher on Devon Island. On Mars, I'm sure there will be a combination of types of terrains. Probably some terrains that are very smooth. Some, like the Viking landing site, sort of blocky but still manageable. And others that might be just like this.